Is our project, the Mezana Pac-Man, the project by Rule 93, 98, and 107. So this Pac-Man game is not just a playable arcade classic. It is a complete DSC case study. Every required topic from the lab syllabus is present and can be explained with concrete runnable code. This project demonstrates both custom data structures like stack queue and also efficient algorithms like BFS DFS. In this project, as you can see, there are three options: login, sign up, and exit. If I don't have an account, I just have to sign up. If I already have an account, I can just log in. I'll sign up for now. Let's say the username is H and the password is 78. Okay, I have to now log in. H78. Okay, I have logged in. Now there are five options: start game, view score report, log out, how to play. Okay, I can see the how to play. We can see that WASD is for movement of the player and Q for quit. You can also see the scoreboard, which is already sorted, and I can also clear the scoreboard from here. I can just return from here and I can play a game to show how the game is working. As you can see, the P is for the player and G is for ghost. Okay, there are three lives. Okay, my two life is over. Okay, so this is how my three lives are over, and I am now back to my main menu. There is it, and now my dipman will show the rest.
I'm Sadat, role 107. Uh, Now I'll explain my part in this project. Uh, as you can see, our maze is stored in a 2D array of size 30 by 60. The length is 30 and the width is 60. This gives us order of one access to any cell. The player score, the player score, uh, the player score history is managed by a custom stack, which is linked list based. This is the custom stack. Okay. Every time a life is lost, the current score is pushed into the stack. At game over, the LIFO order lets us see the most recent life first. Then we have got the custom queue. Then we have got the custom queue. This is used for the ghost movement to implement BFS. Each ghost runs BFS from its position to the Pac-Man's location, moving one step along the shortest path. This also makes the ghosts smart. They never get stuck behind the walls. Okay. The maze itself is modified as a graph. Every walkable cell is a node, and edges connect the adjacent cells. The adjacency list powers both BFS and DFS. Okay. Achha. Then we also used the recursive DFS to verify every dot is reachable from this chart. If any walkable cell remains unvisited, our maze would be invalid. This was my part in this project. Now my teammate will explain the rest of the project.
Assalamu alaikum. I'm Zubair. My role is 93, and I'm responsible for the data management layer, everything related to storing, scores, and user authentication. As you can see, the scoreboard is built on a single linked list of score node. Okay, here's the score node, and we don't sort the list every day. Instead, we also maintain the binary search tree. You can see the binary search tree. Keyed by score. When a new score is added, we insert it into the BSP. The insertion is happening, and then it reverse a reverse in-order traversal gives us the sorted key. Is the in-order traversal which gives us the sorted scoreboard, as we can see from the earlier of this video. And then we freed the BST. Okay, and then we save the scoreboard to file. We sort the linked list using merge sort. You can see there is the merge sort, there is the merging, and for user login we use hashing using the unordered map. Okay, it stores username password pairs, loading the file once is O1 average lookups much faster than scanning the file every day. So this is my part. Thank you everyone.
Assalamu alaikum everyone. My name is Mehdi Hassan. My role is 2307098. So I implemented game loop, input rendering, and integration flow and computation. So the game loop here we can see the game loop is the heartbeat of our internal application. It is a continuous cycle that runs while the player is alive, keeping the game responsive and interactive. Here we can see first the render while true render. So here three main step happens in every frame. First check inputs, user puts his inputs and here while loop checks it, and then update positions if host moves using the BFS path finding algorithm. Then we can talk about check collisions. If hosts catch any player, like if hosts catch any player, they lose a life. So the next part is non-blocking input and rendering. So first, for rendering, we can where first for rendering, we don't clear the full entire screen. Actually, we just do like we just do because that cause flickering instead. Instead, we override the console starting at position 00, drawing only what's new and gives smooth, flicker-free gameplay. Now let me talk about the game flow. Here, here first player logs in, username, password checked using our hash map. Then menu appears, player choose start game. Then the maze initialize. DFS validates that the maze isn't broken, no unreachable areas. Then game runs. Game loop executes using ghost. Ghost use behaviors to hunt the player. Then game ends, score saved, BST organized, leaderboard, and marks or displays ranking. So thank you everyone.